system. There's two types of failing septic systems. One's called a functional failure. Basically, the system's not working the way it's supposed to. Water's not going away. It's a public health risk. You get plumbing backup, you'll get breakout onto the ground, or in some states, if you pump the tank more than 4 times a year, that's a failing septic system. The other type of failing system is what we refer to as a performance failure. It's not purifying the wastewater sufficiently for the situation that it's in. There's a bacterial contamination that occurs. There's a minimum depth to groundwater that's necessary. Generally, it's a minimum of 2 to 3 feet. There's also a nutrient issue, and you're seeing that in living color in all your embayments where the septic system's not removing sufficient nitrogen. So you're getting enrichment and ecological decline. In fresh waters, phosphorus becomes the issue. Sandy soils do very little to remove nitrogen or phosphorus. In terms of good practices, if you have a failure rate of more than 1 to 2% of the housing stock per year, then something's wrong, okay? Good management practices, that's generally what we see in communities, and we've worked with many. The other question is to look at what percent of your systems are in failure mode. And 5 to 10% is really the maximum. If you're over 10% of your housing stock is in a failure mode, we would say you probably have a public health risk going on. Now, that's for functional failures. Performance failures are really dictated by the watershed you're in. But I can share with you in similar watersheds, for instance on Cape Cod, there can be 50 to 75% of the septics can be in a performance failure. So it can be significant. Obviously, for those systems draining to the ocean, one shouldn't have to worry about nutrient issues. If they're draining to the Peconic Bay, you probably need to. Won't get into this slide, but these failure definitions are in code in certain states, okay? And these are the definitions in the state of Massachusetts. It's codified. This one here? Or the one before it. What's the question?
Just couldn't read it fast enough before you flipped it.
I'm sorry. Okay? Yeah. Okay, so again, the numbers are 1 to 2% is the failure rate per year. Anything over 5 to 10% of your stock that's in a failure mode, then you have probably a public health problem. Okay? Okay. The other one, the way that the performance ones are dealt with is the total maximum daily load procedures. That's codified in federal law. So I won't get into that, but it's playing itself out in Chesapeake Bay, Florida, Cape Cod, Long Island Sound, etc. And again, this is codified, and you're about to engage in this in a lot of your watersheds on Long Island. This is what we see of the scavenger plant issues. It's 30 years old. It's old. Basically, it needs complete upgrade. Your receiving station really needs upgrade. Into a more sophisticated, controlled environment. You need to naturally have it financially sufficient. Your market forces are your competitors with going to Riverhead or to Bergen Point, but you've got other factors in terms of travel time and obviously traffic on road. We noticed that 97% of the violations were associated with the denitrification system, and in our opinion, those are not that difficult to solve as an interim solution. Long term, though, the plant needs significant upgrade. This is just a photograph of the plant, just so to show you it's real. And then I wanted to share with you, and the technology, as Mark was saying, this is technology that was typical about 30 years ago. And I'm going to show you some intriguing new techniques that have been developed. Okay. Your challenges and opportunities are that your scavenger waste management plan can become an integral and should be an integral component of a town-wide sustainable management plan. That's typically how unsewered communities deal with this. It's an integral part. There's a potential for effluent reuse at that location. Privatization options there are real and can use some refinement. You've got regionalization opportunities. And again, new technologies have been developed in recent years. And I'll show quickly, and then I'll be done. These are some photographs of some of these techniques. There are mobile dewatering trucks that have been used for years now, developed in Norway, that pump out the septic tank, dewater it, and put the liquid back into the tank and move around. So the advantage of those is that you don't have to run back and forth carrying all that liquid. That works naturally if the septic system is working fine. That's for routine septic management, not for emergency pump outs, because those pump outs are because, frankly, to relieve pressure on the drain field. And so the number of trips that the truck needs to use to empty itself gets substantially reduced. So it's a septage treatment facility, if you will, on wheels. This is an interesting technique that's been developed where they use bags for dewatering. And the liquid gets basically, it comes out of the bags and it uses as a, if you will, dewatering filtration device. Reed beds have been used for septage dewatering for a number of decades now. I also brought along for you, for anybody who's interested, we wrote the septage treatment handbook for EPA 15, 20 years ago. So if anybody's interested, I've got it here and it's available on the web, as well as we wrote a manual on how to do comprehensive planning for communities. And then lastly, subsurface land application. We've engineered systems where the septage was used and injected subsurfacely for sod farms. It's a fertilizer. So the sod farms have used this as a way, frankly, to offset costs and get revenue both ways, from taking it in and then offsetting costs that they're using it in their product. There's even septage dewatering containers that have now been developed, and that's it. So the message there is that there are new techniques available that are a lot more competitive and environmentally, let me call it, benign. So I'll be happy to answer any questions.
Thank you very much. We'll
Right.
take the question.
Yeah.
Theo,
Thank
thank you
you.
very, very much. We can have the lights, please. Wow, that was a full hour of some fairly intense information. We hope we're going to quiz you in a few minutes to see what you've retained. So I think what we'll do now is to first give you all an opportunity to, if you have a question or two about something that someone said, I'd love to get the input of your own questions to each other. One question that I would put to Kevin, to Mr. Phillips, is you made the distinction of saying that the plume at the landfill is improving, and that the interaction between it's the first time I heard that there was a plume under Scav Waste, so I'll say the interaction between the newly discovered plume under Scav Waste and the landfill plume are not interacting. Okay. And I was feeling quite sort of elated and sort of like all bubbly and everything. And then you said, oh, wait a minute, the testing at Scav Waste is not sufficient. So I got a little bummed out. And so I want you to help me sort of level my emotions out on what you said about the efficacy of the Scav Waste plant and how it can be tested in a manner that is, let's just say, scientifically sufficient and supportable as in public policy terms.
Okay, I'll try to clear that up. When we were doing the sampling from 1990,
The last time we sampled was in 2001.
You have to
Or
speak a
Seven
little
Trap.
louder.
but 97 to 2001?
Yes. 4
Okay,
years.
we put those sampling results on the slide, so anybody downloads the slides, they can take a look at it. And there is some violations, and these are the wells. They're not the effluent. Like Mark wrote a report on corrective action, and he said there was notices of violation. That's the notices of violation of the plant going into the leaching pools. Okay, they're not the wells. The wells are actually 90 feet, there's 90 feet of unsaturated zone that this effluent goes through, and then it hits the groundwater table, and then it travels through the well. So it's got a long way to go, and whenever you see a violation of groundwater standards, it's a big thing. And you do have groundwater standards being violated for total dissolved solids. Total dissolved solids is another word for salts.
Say it again?
Salt. Okay, so yes, if you water your lawn with high total dissolved solids, you probably kill it. Okay, but it's not like it's a chlorinated hydrocarbon that's coming out there, but we don't know whether a chlorinated hydrocarbon is coming out there. And we do have a landfill that used to dump septage into a lagoon and generated a chlorinated hydrocarbon plume. So there's a big question in my mind whether or not there is a significant plume out there. Yes, you have a total dissolved solid plume, but I really wouldn't get that much excited about a TDS plume.
Thank you so much. Peter, did you have something to say?
Yes, Kevin, I'm going to use this microphone here, just so people can hear. I had the advantage of being able to review the data that Kevin has, and it was interesting to me that, well, first of all, on the TDS violations of drinking water standards, I noticed that the violation occurs up gradient of the scavenger plant. So the scavenger plant does not appear to be the cause of the TDS violation, but the interesting part as well was that it does not appear that the scavenger plant is even having an impact on nitrogen levels.
I think that's let me address the second one first. The nitrogen level looks like it's operating fine. It looks like the plant is operating fine. The nitrogen levels are pretty low, in fact, much lower than what I expected.
Right.
But as far as the 3 wells that are out there, one is up gradient and 2 are down gradient. The one up gradient, I'm not quite sure is up gradient. And the reason why I'm not quite sure is you have this very large area that you're discharging water to, and you're pretty close to that, right? You should be farther up gradient. And in addition to that, if this is the surface where it's being, if this is the leaching rings here, you have 90 feet of moraine. And what happens in a moraine when you have a clay layer? The clay, this thing's trying to move down by gravity, hits this clay layer, and if the clay layer is tilted, it goes over to Mark and says hi.
Had nothing to do with it.
And then Mark's layer is down here and it deflects somewhere else. So you never really know where this stuff is actually going. And that upgradient well is close enough to the source area that I'm not sure it's an upgradient well. But you may be 100% right. It may be an upgrading well, and there may be another source somewhere.
Is it important,
Can I-
important to know the answer to that question?
Yeah, it is.
It is. Could you tell me why?
Well, could I just clarify a little bit? Because I have a little bit more information. I get to review the groundwater monitoring reports every quarter that we produce for the town. So I'm fairly familiar with the data for the rest of the wells of the landfill, which are not shown on that. And we have additional wells that are between the landfill and the sanitary waste treatment plant. And we don't see those TDS levels. So my feeling from these data is that these TDS levels are reflective of material that's coming out of that specific leaching field rather than coming from another source. So just to clarify.
I'll ask my question again. Is that an important question?
Well, yeah, I would
Yeah.
suggest yes. What I believe Kevin is saying, or
You have to interpret. This is engineer speak. And
right,
I'm trying to get you out
that
of
the monitoring wells need to be expanded.
Can I tell you, I think it'd be helpful if you put a mic to the table. I don't think everyone.
Well, see, they have a mic. It's going to be on the TV.
Yeah.
Go ahead.
The monitoring well network that currently exists is probably inadequate to characterize the situation.
Okay.
That's my interpretation of the situation.
Kevin, would you agree with that? That the level of monitoring at the site is inadequate to decide?
It's inadequate in 2 ways. It's inadequate in the hydrodynamics. It's not really describing the hydrodynamics because you have a you know that this plant is close to the divide. You expect this, if it does generate a plume, you expect it to be shallow, but you also expect it to be deep. And so you need deeper wells in there to kind of describe what's going on. You already know that you have a plume, but you need to have deeper wells. And you also have to know more parameters. You have to take samples and send them to the lab for a whole host of stuff that includes heavy metals like
I hate
mercury.
to push engineering, but let's assume, Mark, and I just want to get your input on that. You agree with that generally, or do you have a different view?
Well, groundwater is not my area of expertise.
Okay.
I
So let me
can
just
say-
ask a question then.
Oh, I do.
Oh, you do have something to say? Oh.
Yeah, the total dissolved solids, as Kevin said, is the salt. There are septic systems throughout the town, especially in the Montauk area, that are located in brackish or saline water. So more than likely, there's a contribution of the total dissolved solids coming from those systems that are adjacent to surface waters.
Right. Well, I'm interested in the outcome, if I might just ask, then Arthur, you could say, if say the test comes out and it comes out one way, let's just say bad way, whatever that is, or it comes out a good way, what is the impact on the policy decision the town's looking to make? To Kevin.
I think that there's some very long-range policy decisions. For example, if it turns out that that these salts are coming from areas that are close to the shore, okay, Montauk or 3 Mile Harbor or wherever, then the question is it making somebody's drinking water down gradient non-potable? And if it is, then you got to make a decision as to whether or not you're going to allow that. Taking salt out of this would be a big problem. It would be very expensive to try and remove salt.
Okay, that's an important point. Wait, Arthur, let Arthur. Arthur, speak up, please, because you don't have a mic.
When the Budget and Finance Committee did its work on this, Bob Nuzzi, who used to work for the the County Department of Health, also looked at these wells and the data from them for the septic waste plant. And his response was twofold. One, that not enough parameters were being tested.
Yep.
The salt issue is one, but the plant's wells don't test for dichloroethylene, don't test for toluene, and those type of materials that could be present. It may not be, but they could be, because nobody controls what comes into the plant. What comes into the plant depends on where the core happens to pick things up. The other thing that Bob alluded to was the placement of the wells may not be correct. Science may have moved ahead of this since in the last 30 years. And finally, he said the wells themselves were not deep enough to basically give us complete data about what's going on in the groundwater.
Engineers, you agree with that, gentlemen? I saw you nodding.
Yeah, just so we're clear, the 3 wells that monitor the sanitary waste treatment plant are shallow water table wells. They're basically sampling the top 10 feet of the water table. For example, the plume that we were looking at earlier, the VOC plume that's associated with the landfill itself, that plume is presently present about 200 feet below grade, about 100 feet into the water table. So it's at a different depth. And we have no information about how deep any groundwater impact associated with a sanitary waste treatment plant is going into the aquifer. So additional depth wells would be definitely a good idea.
We'll wrap this little element
Yeah,
up.
just to put the context about the salt issue, is that, first of all, I would temper any, let me call it, alarm about the water quality contamination.
From it. If I remember right, the 500 milligrams per liter is not a requirement, it's a guidance, a secondary standard, that's number one. So, and the levels here are only about 600. So it's barely over the edge, and dilution will solve that. Any salts that are being pulled in from, let me call it, ocean waters that are seeping in should be corrected by fixing those septic systems that are getting salt water leaking into them.
Okay. I think we've beat that up pretty good. And I appreciate you guys staying on point for that. I'm going to ask a real quick question. P.O., you asked the question, you brought up this idea of routine septic management versus emergency management, and the implication of that on septic planning and decisions on the scavenger waste plant. Could you just kind of give me 2 minutes on what you meant by that?
I'm sorry.
For example, you said that the capacity is influenced by how much emergency
Right,
septic it's
right.
dealing with versus how little ongoing management, predictable, where you could do in the winter when the plant was off, not being used for tourist services, but was, again, a plan versus no plan,
Right.
Context versus no context. I would like you to just address that.
Right. Well, first of all, the size of your septage treatment plant, we think should only be in the 15 to 20,000 gallons per day range, at most. So, how much one needs for emergency pumping is a little debatable. One could start with what you got now, but the goal should be to knock that down to as close to zero as possible. Does that answer your question?
It does.
Yeah.
I'm kind of leading you a little bit because our theory is that we may have as much as 10% non-performing septic,
I wouldn't be surprised.
okay, in the town. It possibly could be more. Right? Now, you said, I had not known this, that level of non-performing septic systems is usually associated with health hazard or some kind of health-related conclusions.
That's correct.
Okay, so that's a cause for concern for me. But it is also the major customer of the septic plant.
That's correct.
So if we were to improve our substandard septic systems, what would that do for the demand for the plant?
Oh, significantly reduce the requirement of its size. Absolutely. And at a minimum, would probably cut it in half in the long term. So, and again, in many states, multiple pumpings on a septic tank in 1 year are defined as a failing system that are required to be repaired. It is a public health
I
hazard.
understand that, and that's something that we will look at in the
Right.
future.
And
I want to give Kim an opportunity to ask a couple of questions. You seem like you're ready to,
No, I'm okay.
you okay?
I'm just agreeing.
One other question I had,
We have a
and,
question from the floor from Dawn.
say it again?
We have a question from the floor from Dawn.
Okay, we have a bunch of questions from the floor.
Okay.
Before I leave this, I wanted to,
excuse me, Dominic, if I may, I brought along a paper I wrote that was in a peer-reviewed journal about 6 years ago on this whole issue of septic system failures, definition, as well as what's reasonable. So I'd be happy to pass those out or leave them here.
okay, thank you. We've got approximately 37 minutes left. So what I'd like to do, again, is give everyone a quick chance. If there's something that was said here, Kim, I especially like to rely on you here since you have, I'm sorry, thank you. If you have any just questions that would help enlighten the audience who will be looking at this on television about some of the general questions that we want to put to this panel while we have them, I'd appreciate that. Do you have any with you just at this moment?
No, I agree that we should be looking at, a long-term management plan. The plant is mainly functioning to treat these emergency situations, and undersized and non-functioning systems in commercial districts, when they have peak demands in the summer season. So we really should be looking at long-term issues of correcting the problem instead of,
with the symptom.
Right.
1 second. Thank you, Kim. I wanted to get this question out. It doesn't matter whether we operate, if we continue to have a plant and choose to have one, are there any environmental concerns that are differentiated whether or not we privatize it or run it publicly? Or are the environmental issues exactly the same either way?
I've worked quite a bit of work at public facilities as well as private facilities.
Can you speak a little louder?
Working I work both in public and private facilities. There are facilities run by municipal operators that do excellent jobs as well as less than excellent jobs. In the private sector, same thing. That some are stellar operations and others are less than stellar. So obviously, if you're with a private contractor, you definitely want to have oversight. You want to have parameters and metrics that are followed up. And in municipal operations, the challenge is, as these systems get more sophisticated, do you have the in-house expertise? There's less and less people entering the waste treatment field. And certainly on the municipal end, I see a lot that are retiring now. So there's an absence of skills on the municipal market right now.
Mark, I want to take advantage of your expertise for one other question. Could you explain for the audience the context that we're operating in right now in terms of CAP, the corrective action plan? Could you give us a sort of a summary of the options and the time that we have in order to make decisions? You want to come to the podium and do that.
The corrective action plan, which was approved in November, gives the town approximately a maximum of 2 years if it elects to bring the facility back online in the operating mode to meet compliance with the existing speedies permit. Obviously, if there's something less than that, as if the facility wants to close, that could be accomplished certainly within that 2-year window. Presently, under the cap, the town is permitted to transfer a maximum of 10,000 gallons per day of septage from the site. There's no treatment going on for discharge, but there is removal of, there's some pre-treatment of the material prior to it being hauled off-site to Bergen Point and or the Riverhead sewage treatment facility. And that is a factor that has to be considered in that if the town elects not to be in the scavenger waste business, then you have to look what are the options outside of the town. And there's presently not a tremendous amount of excess capacity for scavenger waste. We have, Cameron Engineering has prepared a Part 360 transfer permit for the town for submission to the state that has about $200,000 worth of improvements, and that would allow, if the state approved the plan, to transfer up to 45,000 gallons a day. Again, no treatment, but it would at least increase the capacity, because with the summer months, historically, the 10,000 gallons per day capacity is not going to be sufficient.
Okay, I've asked enough questions. Oh, you had an answer.
No, I have 2 questions. One question was, we've heard from time to time that the cost of rebuilding this plant is astronomical. And yet, when I met with Walter Hilbert of when I met with Walter Hilbert of the that county Department of Health, his estimate was building one of these plants today is roughly $50 a gallon. Maybe it's $100 a gallon. But if you're talking about the kind of size plant that P.O. was talking about, you're talking about a cost to build a brand new plant of $2 million, $3 million. And yet the number we've heard thrown around has from time to time been this facility is worth 20 or 30 million dollars, which seems out of kilter here. The other thing he said, and which could be right or wrong, would be that if there were ever an emergency where we were running out of places to transport our septage up island, he didn't think that the permitting process in that situation would be defined in years, but rather doable within a rational period of time. And I was just wondering if P.O. and Mark, you might react to that difference of opinion.
Take a couple of minutes if you like.
Well, from a regulatory, when they say a fairly insignificant amount of time, as far as my experience with, if you regulators are watching the show, that can be a protracted window, even if you think it's something that can be done rather readily. The pricing of the facility that Walter said, $50 per gallon, that's for wastewater treatment plants that are continuously fed. So if you had a sewer system feeding in the scavenger waste, PO even had the slide. In your case here, the waste is about 10 times the strength of normal domestic wastewater. Domestic wastewater of 200 milligrams per liter. Historically, it's coming in here solids 2,000 milligrams per liter. The BOD is 2,000 milligrams per liter. The nitrogen is 500 or 600 parts per million, significantly greater. So even though it's a smaller flow at your plant, 45,000, the organic loading, the solids loading is significant. It would be almost like a 300,000 or 400,000 gallon a day plant from a loading perspective. So the $2 million, I don't think that's an accurate number at all. Because I was one of the individuals that was throwing a large number around. I said if you started from scratch and you had a blank piece of paper to go through the environmental, to go through the regulatory permitting, to go through the financing, and going through the permitting and the construction, that in today's dollars, it's probably a $15 million exercise to get you a state-of-the-art facility.
For 20,000 gallons.
For 45,000 gallons. Okay.
Yeah, I would agree with Mark. The $50 to $100 per gallon per day capacity, that's wastewater, not septic. And septage is a sludge treatment plant. So you've got a solids train and a liquids train, and the liquids train is 10 times the strength. So when you prorate that, $15 million is reasonable for back of the envelope purposes.
So would you say, if for example, we were going to do a packaged sewage plant for a low-lying area like Montauk,
Right.
that might be $50 a
50 to 100, depends. There's a lot of depends.
Okay.
Yeah, we do those all the
Yeah, I know we
time.
do. That's why I asked the question.
And we guarantee. Yeah, that's a typical number. Site conditions, et cetera, very influenced.
Okay, thank you. Excellent question, excellent answer. Kim?
Mark, I had a question for you. For the modification that you're doing for the 360 permit for the state, is that $200,000 to $300,000 only for expansion, or does that include odor elimination?
The 200,000 of that 200,000, 120 is cleaning up the existing tanks, getting rid of the sludge, getting the residuals, getting the material off the beds. So of the 200, 120 is cleanup. 80 is the other 80 is fixing up the influence station, creating a truck transfer loadout area that has containment in case of a spill, and just some routine. There's pumping, piping, valves that have no longer functioning. But it's not. But it's increasing the state right now has a restriction of 10,000 gallons a day for transfer out. So
right.
Without any improvements, you're not going to move above that 10,000 gallon a day registration.
Okay, I want to be kind to our audience. I got one request. Kevin is asked to, you have a question you want to ask, Kevin?
A 1 minute statement, if I may. Thank you. I appreciate it. Sylvia and Dominick, I appreciate the opportunity. I think this is the beginning. Kevin McAllister, I'm your Peconic Bay keeper. Things have to resonate probably 7 to 8 times with the advertising world to stick. So, I'm probably 25 times here, but a few points. We talk about bacterial contamination and these systems, and I know Pio talked about it. Ultimately we have to consider sea level rise, and we are seeing an expansion of the bays. So some of our older homes where we had that separation from basically through dry soils to the, to groundwater, was adequate to have that kill effect for bacteria, in many cases is now negated because that water table has come up. So these lower lying areas with the expansion of our bays into, again, low lying streams, many of these systems are now immersed. So we have that bacterial component affecting shellfish beds and public health. Nutrients is a big issue. Obviously, we've seen the trend from western bays out east. It's an alarming trend. The studies that are coming out are certainly demonstrating higher nutrient levels in our groundwater, and really all points lead to collectively these septic systems. I think, again, this is a very positive conversation that has to go forward. A couple of misnomers, and I know we're dealing with septage, pump outs. Let me point this out because this has been tried and true with respect to studies in Buzzards Bay. The notion that we pump out these systems, that somehow we're removing the nutrients, is very negligible. And ultimately, as groundwater is enriched with nitrogen from septic systems, nutrients, as travel to these water bodies, our ponds, our streams, our bays, they're enriching them, triggering these algal blooms, fish kills, low oxygen levels. It's a chronic cycle. So this is a big picture thing that we have to deal with some kind of management strategy. The last point, I often hear from Suffolk County that we're going to move toward upgrades. Well, in their vernacular of upgrades, they're talking about current code. And that means adequate separation to groundwater, the settling box, adequate leaching fields or leaching rings. That does nothing for nutrient removal. In my vernacular, upgrades mean we've got to move towards denitrification. These are entirely different systems. We've got to start talking about that. So thank you for the time. My recommendation, I'm sorry, infomercial. No infomercial. It's a clean water infomercial. So on your behalf, thank you.
I want to make one point that Kevin spoke to, is that there is a bit of a argument amongst advocates over what is upgrade. And what I've always been concerned about as I've been involved in these conversations is that I don't let that argument get in the way of progress on the issue. Because if we can't settle that particular element of what is an upgrade in the grand scheme, I admit that Suffolk County has moved slowly in this area, and certainly not to your satisfaction. But I am encouraged that we are moving forward on it. And if for a community that has no plan, no upgrading in place, we should not let failure to come. I think we need to come to terms, an agreement on what that is. It's an important definition, and we will hopefully agree on what that is. Two questions. One, here's a statement from we should do what America does best in efficient engineering, high-tech incinerator, now called plasma generators, shared by the 5 eastern towns. Why isn't this being discussed?
Plasma?
Plasma generator. Am I say something you don't know, or what?
I think that was Doc Brown on Back to the Future.
Yeah.
Yeah.
Okay.
It's not I'm not familiar with it,
Right.
but if I, it's not a proven technology.
Okay. Yeah. Fair enough. I just I get points for asking, so that's an important element here. The other where's my takeaway question? Oh yeah. Any questions from the audience that I'm not covering? Whoop! Wait a second. A little too energetic.
I was plasma generator. 1995, 1996, I forget what year, but we did discuss the 5 towns an incinerator. That
Oh,
5 towns
maybe that's
get
what-
together and have an incinerator, one place they all go to. So what about that?
But that was for solid waste,
Solid waste.
not septic management.
No, septic, now today I've heard it will be
Okay.
septic.
I'll tell you what. We have a promise to inquire, and we'll report back. How's
Does
that?
anybody know?
Well, we can tell you that incineration of septic waste is going to be incredibly expensive. You're going to spend a fortune on the energy cost. You evaporate it. A lot of water. It's going to cost a fortune.
The 5 towns?
It doesn't matter. It's a fortune. You're not going to like the bill.
Suppose you're also incinerating solid stuff at the same time, can't you?
It's better to produce electricity with that heat.
Dominic?
Yes.
Can I ask a question?
Yes, certainly.
You may not be able to read my handwriting. This is for Kevin. The last time you did any testing at the Scavenger Waste Plant was 201, okay? Now, isn't it a true fact that the one area over at the whole complex that there was a Superfund site was the lagoons, correct?
Yes, that
And
was,
the little lagoons was where we dumped all our septic. So my point is, out of all the areas that should be tested the most, should be the Scavenger Waste Plant, because that was the one place on the site that was a Superfund site cleanup. And you're basically dumping, trust me, the carters that took everything to the lagoons are the same carters that are taking everything to the Scavenger Waste Plant.
I think that's a
Is
good,
that a true statement?
I think that's a good observation.
There's one difference, though, between the time that the septage was put in the septage lagoons and where it's taken to the plant now. In the old days, we used to treat our sanitary systems to get them to perk better by putting chlorinated solvents into them. And that resulted in the problem at the septage lagoon. That is no longer a practice, or at least shouldn't be. So the risk of getting chlorinated solvents into today's septage is much, much less. I agree it should be looked at, but I think the risk of that problem is much lower today than it was back in, let's say, the 70s and 80s when we were still using those septage lagoons.
And just to dovetail that, the plant itself is removing solids. The sludge, grit, it's going through a biological process. It's filtered at the end. It's vastly different than dumping raw septage into a lagoon.
Yeah, but the sludge, for a lot of years, I know they're removing it now, but for a lot of years at the Scavenger Waste Plant, they took the sludge and they just put it in drying beds, so it was still sitting there with rainwater hitting it.
No, the drying beds, which are no longer used, but at one time they were
But
used.
for the biggest part of the life of that plant,
The water
the
that
drying
went
beds
through,
were that way.
the water that went through the drying beds goes back to the front of the plant for retreatment. And then once dried, the material was taken off in a solid and taken to a landfill. So those beds that are open, still open to this day, are connected back to the front of the plant. So any rainwater that comes on into those areas, and there's only some material left on one bed that comes back to the front of the plant. So that's much different than taking raw waste and putting it into a pit.
Bonnie, does that answer your question? Okay. But it does raise another question that I want to ask. What is the most important information needed for East Hampton to have and consider before making a decision to run or lease a new plant, all right, with upgrades or without? Use as a transfer station or closing the plant? Again, what is the most important information needed for East Hampton to have and consider before making a decision? ...
Is that for here?
Yes, sir. No, sorry, more.
Every-
We'll go around the table.
P.O. mentioned it, Kevin mentioned it. If you have a plan, unfortunately, we have a tendency to look at 1-year windows, 2-year windows, 4-year windows. Kevin's talking about the gradual rise in sea level. That's not happening today, but 5 or 10 years from now, you're going to see it. This facility, if it's not in the plan, that's what you need to know. I always tend to look at 5, 10, 20 years down the road. I think this facility has a lot of potential to be used not only for septage, it could be used for if areas were sewered adjacent to waterways and that material collected and brought up to the plant, the liquid portion. There's a lot of opportunities. You could pump wastewater to this treatment plant.
You're saying within the context of a
Of a comprehensive plant.
This plant may have
a piece. It may
Okay.
have a piece to play.
Okay.
But again, you got to be looking out. If you're talking about a septage management plan, then you got to develop the plan. You have to institute the plan.
Let me ask you this question. Even with that bit of information, it does not matter how we ultimately choose to manage the plant, because it could be private, it could be public. We haven't yet opined on that issue, but the issue itself does not have a bearing on how we plan for it.
You have to plan. That's step one. Does this facility have a role in the long-term plan? Now, nobody has really mentioned cost.
Right, no,
We're gonna
Oh,
get
I'm sorry, I'm sorry. So if there's a plan, and the plan is either a comprehensive septage management plan that says, hey, everybody that has non-conforming systems has to get it upgraded, or at a very, very basic minimum.
That is the
meeting
most important
today's
information
things.
you think we need to
I think so, I think you need to have a plan.
Okay.
I'm going to give you my opinion on this, and
Louder, could you give it louder?
Sure. I'm going to give you my opinion on this, and my opinion is that we would recommend that you don't move forward with any decision on this plant until you determine whether or not the existing plant has caused an impact to your groundwater. And
So it's environmental.
it's an environmental issue, and if there is an impact, you have to determine what the impact was and whether or not you want to correct that or just not build the plant. And it's too much of a risk to the town to build this plant because of whether it be quality control issues out there. You know you have a violation of mercury out there. So, Bonnie's concerned about what's going through this plant, I think is a very good one. And that issue really has to be addressed. And even if you found out that there was an impact, you certainly could say, well, let's develop a quality control manual that loads come in. We're going to have a small laboratory on site and test this. Make sure that it's not serious contamination that's going into this plant.
So if I just read you correct, environmental analysis first, some kind of contextual planning second.
Yes.
How about justification analysis? Is there any kind of justification analysis on the need for a plant, period, or one that's developed in the context of a comprehensive plan? I.e., say, like, for example, we were to have significantly reduced the amount of unexpected flow into the plant.
I think justification analysis is always important, but I think it's probably phase 2.
Okay.
If it turns out that there is an environmental issue that's significant here, then that's obviously going to weigh heavily upon whatever plans you come up, whether you come up with justification or not.
Well, then what would that say about the need for a comprehensive plan if we have an environmental analysis that says, well, we got a problem? Where does that place the need for a comprehensive plan?
I think a comprehensive plan is still very much needed. If you don't have a piece of that comprehensive, then you have to work without that piece.
Right. Pio? I'm sorry. Let me just get Pio while he's still fresh in his head.
Yeah, I would urge that these things would be done concurrently, that the issues are first sizing, how big should the facility be? But I'll go back to the first slide I presented, which is how big does it need to be? What's the cost competitive issues? It may be that go buy capacity from Riverhead, go buy capacity from Bergen Point.
You said buy capacity?
Buy capacity at their plant. That's not uncommon that you would have intermunicipal agreements. But you need capacity somewhere. You either have to have it here or you have to have it someplace else. You've got to run the numbers economically. You may, for your own preference purposes, say that we'd rather pay the higher price because we want that ability not to be subjected to somebody else causing trouble. That's not uncommon. In terms of the environmental, I agree, but I would urge, first of all, there's no smoking guns, number one.
You mean, sure there are no smoking?
Well, there's no smoking guns based upon the data that exists. We know that the data that exists needs to be expanded, that it's not properly expansive, it's not sufficiently.
So let me just restate that. You said there are no smoking guns on the existing data.
Scavenger plant existing data.
Thank you.
Okay, we also know that there's deficiencies in the well makeup. But there are techniques to provide insurance that the system will not discharge contaminants. You know, fish tanks are used in certain plants at the end of it, so you can do bioassays at the end. You can hold water and treat it, test it before you discharge.
Thank you so much. You had a question?
I have a couple of questions which I wrote down, but
Oh.
you're not getting to them. One of them is, do we know to what extent our town's septic systems and homeowners are only pumped on an emergency basis? In other words, do we have data from the people who
No, we
always
haven't.
and answer the emergency calls, and do they increase in the summer, decrease in the summer?
Now, that's one of the goals of organizing a plan. What we have now is, what do you call data that's?
Anecdotal.
Anecdotal data, all right, which is that we have a bunch of trucks going to the plant on emergency calls in the 9 o'clock at night, various other times at night, which give anecdotal, information on the kind of call that it was. But the need for that is part of the elements that P.O. was talking about earlier. And that is developing a database and a data source that is reliable so that engineers can use it to design something.
Also, it doesn't seem to get back to what he said, it's not that hard to establish kind of a manifest system to see.
Agreed.
where
I agree with that.
hot loads.
You do a manifest system. It's simple. It's done routinely.
Now, we've got 8 minutes. Oh, absolutely.
I just wanted to ask Kevin, because I know you're doing the testing there for the sanitary landfill. Do you feel the town has adequate enough test wells, whether for the landfill or the scab plant, towards the Stony Hill area? Because I know the Stony Hill area, going forward, really is going to be our water source. Because that really is where the pristine water is. That's where Suffolk County Water now, since the last of your testing, has put a well field up on Accabonac. I mean, I know our test results from the golf course say everything's going northeast. I know what you're saying, it's northwest. And I think that's part of the confusion that comes out of the landfill because of the divide. And so my concern is, I wonder if the town really has enough test wells that maybe some of this could be going more east. Right now, based on what you put in, could it be going east rather than west, or some of it going east? And I think, maybe there needs to be more test wells. I mean, to me, it's always about information. And my biggest concern is the Stony Hill aquifer. Because for years, we all thought there were lots of areas to get water. We have plenty of water here. The issue is quality. And because we've lost a lot of the farm fields as potential places because of the farmers, what they did prior, there's a lot of temic, so there are a lot of areas we can't now take water from. And that the Stony Hill area basically takes care of Amagansett, takes care of Springs, and it also takes care of Montauk. And that, to me, more than anything, should be one of the largest concerns, and that maybe the town needs to put more test wells in to make sure that whatever's coming out of this location is not going that way before anything is done.
Right. That would be part of what we might call a robust financial, environmental inquiry. And Kevin, I think you were pointing to that being a very high priority and recommendation coming out of this forum. Arthur?
I think one thing about that too, any robust testing should be time sensitive. Remember, the plant has now been closed for about 3 or 4 months.
Oh,
So the longer we delay in doing that,
12 weeks, all right.
the more possibility there is that we won't get the right data because some of that pollutant may have dissipated itself someplace else.
Let me ask Mark. Mark, we've got 104 weeks.
But we got a 9-day extension.
No, I don't think we got a 90-day extension on.
The extension,
Did we?
obviously, the regulatory agencies, if you're upfront with them, and
Right.
say, this is what we're doing, as long
Okay.
as long as there's communications,
Right.
I don't see a problem.
Okay, let's just say we said, go out and get them, guys. Give me an environmental report. How quick can you get it for me? Kevin?
That's your question.
Do I have 2 weeks? Do I have 1 week?
In other words, give me a planner's perception of what I'm asking you to do and when I can expect to get it.
Yeah, I think what we would do is we would sit down with probably the runs of the model that we did in 2003, look at what what we expect the
Sounds like 6 months.
vertical. My guess is at the minimum it would be 3 months, and at the maximum it would
Okay,
be 6 months.
that's fine. I appreciate that.
Yeah, I
think one issue here has to do with educating the public, you know.
We're trying.
Most of us,
Well,
well, I know
I'm
that,
giving it a
most
go.
of us do not have our systems pumped or anything else unless we have a problem.
That's correct.
Why not have some kind of incentive program for
We get that.
for people to have some kind of regular basis on which they have their their systems pumped, and just to make sure that everything over a long period of time on a regular basis is in good shape for the town as a whole.
It's an excellent suggestion, and I might say it's so good that it is generally included in almost every comprehensive septic management plan that is designed for communities like East Hampton across the United States. So it is a feature of a plan that is common. Financial incentives in an organized manner so as engineers can plan around it. It's an excellent suggestion, and one that is known to the engineers. It's an excellent suggestion.
Dominick, Sylvia, thank you. It seems to me when you look at this situation, we're talking about many, many different elements. And it's difficult to pull it together when we're coming from all different.
We're trying.
I know you are, but I think if we were to take a group twice this size and say, just in one word, what's your concern? I think we could probably limit it down to our groundwater analysis, the future function of the plant, and cost.
How about context? How about context?
Context?
Yeah, context. And what place in our community does the plant play? One of the things that I believe have been missing, and I would only add it to your list, which is an excellent one, okay? Just that context is critically important in my view, all right? That we know what the plant is doing and why it's doing it. And that it's part of, okay, not the answer to, but part of a plan.
Okay.
All right, that's I would only add that to your very, very
So now
excellent
we have
observation.
4 options.
Yeah.
So I think to limit it down, what comes first? And what comes first has really got to be what's been hit on very heavily up front today, is our groundwater environmental analysis. Pio, you said no smoking gun. Do you feel that's the overall groundwater?
No, I'm frankly just looking at the data that's been presented and saying there's nothing there that I've seen that your hydrogeologist is. Now, but I would like to add that there's been an acknowledgement, and we know that the network is inadequate. So I would suggest that, especially since you're on a sole source aquifer, you need a network throughout the entire town.
I agree with you.
And that should be, you should have a comprehensive groundwater monitoring system with, Kim and I were chatting about it, that's live.
Right.
That's with a modeling, so you know all of these things, and this is not a, oh geez, let's go do this now. These things should be ongoing all the time. And that's what's missing rather than
Right.
reactive.
Well, I think we have general agreement on that.
When this was set out,
Okay.
there were areas, because we did it a little bit on the cheap. We didn't do, as Bonnie mentioned, Stony Brook, Stony Hill. We need to spread out a little bit and see where we are before we can even begin to answer questions of.
I expect you'll see in your groundwater that Kevin knows is that you probably have groundwater contamination from nitrogen from your septics that's going to the bays. Now,
We don't think there's a lot of question about that.
Yeah.
But, scientists may need to prove it. Listen, we are down to the short hairs. We're talking 3 minutes here.
I submitted.
Quick, we didn't get to all the questions. You got a question? Fire it. Fire it out. Fire it away. No one's stopping you from saying, ask it. Ask it. Ask it. Quick.
Just read my thing.
No, ask a question. I don't know where your question is. I've got 200 up here.
For the layman here, can you please define upgrading well and downgrading well?
Okay.
Do you mean downgrading it?
No, I don't know what the term means. He kept using
Okay.
upgrading.
Downhill, uphill.
Down. Okay.
He said one
Okay.
upgrading and 2 downgrading.
Okay, in a simple answer that everybody can understand, it's the velocity, the known velocity of the groundwater. Where is that path going? And we want to, if this is the source here, we want to get up gradient of that velocity so that we know that this source hasn't contributed. And then we want to get down gradient of that source so that we can say that the impact is due to that source. That's what up gradient and down gradient means. Think of it as a velocity, or think of it as cars moving along a one-way street. The up gradient observation is what cars are further up gradient.
They're coming onto the street. They're coming onto the street.
Lower downhill. Water flows.
Yeah.
Reclaiming my time.
Water flows down gradient.